Hello, welcome to the 6th Technical Labs. Today we're going to be running through SSH. So here's the hard pitch for SSH. SSH seems like a really boring thing, but it's incredibly widely used. So if you do anything with like remote management, so that means you've got a server and you want to manage that server, like run things on that server or change how that server works. Or if you want to, a lot of the time if you have like network switches in your house or any part of your network, in either a building or in your home or wherever, you can normally SSH into the switch and edit things on the switch. I have a Raspberry Pi set up, which I SSH into to configure things on there. So that's what SSH is used for. And these remote management skills are incredibly widely used. A lot of companies want remote management skills so that you can, interact with their servers and run code, change how things on their servers are working. And in our course, it's really useful for because so with C especially, it can run differently on different machines. And so you might have code that compiles and runs on your machine, but not on another like your marker's machine. And if you ever need to, say, no, my code does compile and run, it's just the marker's machine. The one source of truth on that is the Bath Linux servers, or linux.bath. And if you can prove it runs on there, and you've tested it on there, you can have your marks refuted and make sure you get full marks. So it's really important. The university does require it. If you do want to do testing with things like the chat server coursework coming up for first years, you will need to use it to connect to linux.bath to run it on there. So it's a very useful thing. So what is it? So SSH stands for Secure Shell. As always, programmers slightly dodgy with their acronyms. And it's a cryptographic network protocol for communicating securely over unsecured networks. That's almost directly pulled from Wikipedia. So SSH is used to secure any network service, but more commonly it's used for sort of remote command line access, remote logging in, and remote command execution, and file transfers. So SSH is merely a protocol that you can then use for other things, right? So the vast majority of the time, though, it's used for just logging into a remote server and executing commands or transferring files. There is one exception to this, quite an interesting one. Git can work over many different protocols. If you've done anything so far, you've probably used HTTP, which is sort of the normal way to interact with Git. But Git is actually pretty inefficient over HTTP. It's just not very fast. If you connect over SSH instead, which you can do, Git works much faster over SSH. And so a lot of people like using SSH. It can also be much more secure. So that's another way people are using the SSH protocol. So put simply, SSH can do many things. In this lab, we're going to use it to access a command line shell on a remote computer, usually a server. This will typically be a Unix shell. In this case, it will be linux.bath as a Unix shell, unless you do some really funky things. which don't. Uh, um, and if you don't understand how to use the Unix command line, we have done it. The first lab we ever did was on the Unix command line. I recommend you watch it or read the notes. The notes are available as always. Find the link on the Discord or Teams. SSH is extremely widespread. It's supported on all the major desktop operating systems, Windows 10, Mac OS, and the vast majority of Linux distros. As always, you can't say anything about Linux concretely because there's so many distros out there, they're all different. I'm sure some of them don't have SSH, but all the ones I've seen have done. And the vast majority of networking equipment supports SSH, and indeed SSH is pretty much the primary way of connecting and configuring remote like networking equipment and servers. Over half of servers in the world are only connected to via SSH, which is kind of crazy if you think about it. Okay. All right, so how does SSH work? So SSH is just a protocol, which means it's just a sort of system that different computers agree to in how they're going to talk to each other. Okay. So SSH is made up of layers. The first layer is the transport layer. Okay, and this layer is used, so we have our computer here, and we have the remote server here. Okay, and we set up a transport. This is not, and so this just reaches out to the server and says, would you like to talk over SSH? And in this level, there's different versions of SSH with different sort of intricate details. So they find one that they both have in common, they can both work with. They define a cryptographic protocol to use. And so they just work out how they're going to talk together. Then we have the user authentication layer. So this is where, by whatever way you want to, you authenticate with the server. So this can be either just like logging in with a password, probably most common, and that's how we're going to log into linux.bath, or it could be cryptographic keys. So you may have heard of things like SHA keys. It's quite common, and that is more secure. You don't need to put a password in then. That's really useful. We're not going to cover that here, but there's some really good tutorials online if you want to get into that. We're mostly not covering it because linux.bath doesn't support it, or at least I couldn't get it to work. So that's the user authentication layer. So this uses the transport layer. So this is cryptographic, because we've already established the cryptographic layer. It then sends the user authentication layer over that cryptographic layer. And then lastly is connection layers. You can have multiple of these, how many you want over one SSH connection. Normally you just have one, but whatever. And this is where we actually send data. So we make these two layers, then we can put whatever we want on top of it. These carry channels of information. Channels can be, and they carry info back and forth. The channels can be pretty much anything. They can be, in the case of today, we're going to use it for sending the input to a terminal and the output of a terminal back. You can use it for Git, as I said earlier. You can use it to transfer files. You can actually send any network communication over SSH. Don't, but you could, and people have. And because nearly all computers support it, it would be accepted. SSH connects over port 22. There's some slightly entertaining stories over why SSH uses port 22, if you want to Google them. It replaced, Joe looked at me confused. So there was an old protocol that worked on port 21 and an old protocol that worked on port 23. And a guy just wanted to replace them. And so he wrote a really formal letter to the people who manage this stuff. Can't remember the name of the body. And he said, like, I'm making this thing to overwrite these. I want a port designated for my SSH protocol. Please, can I have one? I think port 22 would suit me well, but I understand. And then they sent back one sentence response going, port 22 is yours, thanks, and then a name. And that was it. And since then, port 22 on all computers over the entire network is SSH. I find that entertaining, at least. Okay, I've just dropped my pencil. Thank you, Joe. What is How are we going to use SSH? So as we've said, SSH is only a protocol. It's not a program. We need a program that's going to use SSH to connect to our servers. By default, all major desktops can accept an SSH connection. So any Windows computer, it was added like halfway through Windows 10, like in a later release. So the newer versions of Windows 10. All of macOS, unless you're running like macOS 9, but again, don't. And the vast majority of Linux distros have SSH support, so we can connect to them. We just need an application on our computer to work as our client application, to sort of display our side of the connection. And we're going to use something called OpenSSH, which was founded by the inventor of SSH, and it's a great little program. Do we have any questions before we get started? Cool. OpenSSH comes installed on nearly everything. It comes installed on macOS, it comes installed on Windows, it comes installed on the majority of Linux distros, and BSD installs, but I don't. If any of you are running BSD, please message me. I'd be fascinated. Anyway, so OpenSSH comes installed, and it brings a bunch of programs and commands to your computer. So if we want to connect to a server and open a command line, we would do, the program is called, SSH, and then the name of the server we want to connect to. So in this case, it's going to be linux.bath.ac.uk. And this will try and log in, but it will try and log in with our computer's default user. In this case, for me, that's Alfie Richards, which is my name. I have very boring usernames. And so if we want to change, but obviously my linux.bath uses your university username. So obviously this isn't going to work. Oh, no, never mind. I've done some stuff that changes this. Don't worry about it. Normally that would have said you're connecting with Alfie Richards at linux.bath.ac.uk. So to change that, we're going to put in the username. My username is AR, that's the wrong way around, 2227 at linux.bath.ac.uk. Putting that in, it's going to prompt me for a password. So this is the user authentication layer. The computers have already established a cryptographic layer. Now we're on the user layer, where they're just trying to establish a connection, which we're not going to do yet, because we're going to do that later. So there you see we use the syntax username at server address. This could be an IP address, it could be a URL like we've used here, but that is up to you. Okay. We can also do file transfer over SSH. And the way we do that is we use the command scp. SCP, again, comes with OpenSSH installed on nearly everything, and it stands for Secure Copy, and it's using it stands for SSH Copy. And then what we can do is we can, you can see something I was trying to do earlier, so we can specify a file. So we're going to copy a file, and then a user, and then we specify a file path. So I'm just going to use a dot, which means put it wherever I want it, wherever it logs into, which would be my user's home directory. But again, we're not going to do this yet. That'll be later. Cool. And we're, actually, yeah, we'll do that later. And then we can do that the other way around as well. So we can say, oh dear. And then, so we put our username, the server, and then specify a file path. And then save that, and then specify a path on our local machine, and that will copy a file from the server to our local machine. So that's how we connect to a remote shell. That's how we copy files to and from. And then lastly, we're going to talk about how just to execute a remote, what word am I trying to say, Joe? Remote command. So the way you do this is you do SSH with your username and server, and then you just specify a command. So here we're going to do ls-a. This is going to require one password. So I'm going to put in my password, and then this is going to run the ls-a command, and then it's going to return all of the results over a connection layer. So here you can see all of the stuff I've got lying around in my linux.bath. There's a lot in there. Oh boy. Okay.
Lots of problem sheets.
Lots of problem sheets. Because, as I say, you need to run everything on linux.bath. Otherwise, if it's wrong and it won't run on linux.bath, you can get marked down. Okay. Okay. Let's go on to any questions so far.
Why is your username not elitehacker6969?
Well, it's just not.
Carry on.
I don't know how to respond to this. Do they think that would be an apt nickname for me? I don't.
Well, later on, the Alfie program will surely be coming.
Oh dear. Okay, so let's run through an example of doing all the things I just described with linux.bath. Linux.bath is great. Linux.bath is linux.bath.ac.uk, often just called linux.bath. It's an Ubuntu server set up for Bath students and staff. You log in with your university username and password. In this example, what I'm going to do is I'm going to upload a Java file to linux.bath. Then I'm going to log into linux.bath, compile the code, run it, and then I'm going to save the output of the program and copy it all back to my computer here. So I'm going to copy the file there, run it, copy the file back, copy the output file back, so that we can do it. I'm not going to be explaining all of the commands I use here. I'm going to assume some knowledge because we ran through all of this in a previous lab. The first lab, we talked about Unix commands, and so if you are confused by anything like that, please go through that lab, and if you are still confused, message either myself or Joe. Okay, if you go to the notes, you'll find the link to the program I'm going to run. It's just an example program I found online. It calculates the greatest common divisor of two numbers. It's pretty simple. So let's get going. So the first thing I'm going to do is I'm going to SSH into AR22227 at linux.bath.ac, and I'm actually going to make a command. Okay, so this is going to make a file on my remote, on the linux.bath. Is that still copied? No. Let's copy that. Okay, so it doesn't output anything. The make dir command doesn't output anything, but we can run this command. So I asked it to make a directory, and now I've asked it to run the command to list everything in my home directory. And you'll see we have our folder here, gcd dir, because I'm very creative at naming. Note that it's prompting me for the password each time, because we are, once the SSH command ends, all of these layers get removed, everything's gone. So now we need to copy the file we want to run onto linux.bath, and so we're going to use the scp command. So the file's just called gcd.java, so that's my local file, it's on my machine here. If I run ls locally, you will see gcd.java. So scp gcd.java onto AR2227 at bath.ac.uk. Colon, where do we want to save it? We want to save it to What do I call it?
GCD dir.
Won't autocomplete, unfortunately, because it would have to communicate with the remote server. At linux.bath.ac.uk, I make that error a lot. There we go. Okay, so it's a very, very small file. It's 617 bytes, so it sent it very quickly. But if it was sending slower, this would display a nice progress bar for us, and this would count up to show how many files. You can also list a bunch of files in the SCP, or you can specify the -R flag to transfer over an entire directory, but that's not what we did in this case. And now if we run the same command as earlier, ls, oh no, let's not do that. So we're going to do ls gcd dir. Okay, so I sort of listed the contents of this directory. You can see gcd.java is now in there. So let's connect to linux.bath. So this is going to open a shell in linux.bath. That did not work. 1Password is very good and very secure, and it removes your password from your clipboard after a little while. But it can be a little bit irritating. Okay, so now we're in linux.bath. If I run ls, you'll see all these files again. This is where we are. You can even see gcd dir. So let's cd into gcd dir. And you can see gcd.java. So that's the file we want. Okay, and then we're going to run the Java compiler. Thankfully, the nice folks at the Bath IT department have already installed all of these things that we might need. So the Java compiler is already on there. Like every compiler you could need really for any of the coursework will be on there. Okay, so we're going to compile that, and then the -d flag just specifies where I want to output it. Oh dear. Oh, I remember. Whoops. Taken us. I fixed this in some of the file.
Java util staff.
What is it? What am I?
Java.util.staff, I believe. Embarrassing if I'm wrong.
Do I put a semicolon after that? I think I do. Okay, so I'd forgotten to add something to the file there. That's fine. Now it compiles. Great news. So here you can see this is gcd.class is the compiled Java code. And now I'm going to Java, which starts the Java virtual machine. We're not going to go into the Java virtual machine today. Ask Michael if you want more details. So we can take Java GCD, and then we're going to run this into a program called T. It's called T. It won't autocomplete for me. And all that T does is it prints the output and also passes it along, so that then I can output it to. Okay, then I'm going to output it to just a text file. So the result. So I'm going to run this program. And I'm going to save the output to a text file. So I put in two numbers I want to GCD. So 65 and 130. That did not print the output.
Printed to output.txt.
Yeah. I don't know why that didn't print it out. Oh, I know why. Whoopsie whoops. I think it should be. Oh no. I think it should be like that. There we go. So 15 and 48. That's 3. And then if we look at the output, there you go. You can see the output of the file. Cool. So now we're going to exit this SSH connection. Okay. So we went into linux.bath, we ran some code, and now we're out. But we want that output file, right? That we just want, say it was massive and we wanted to look at it. Obviously it's not in this case, but sometimes it will be. And we want to look at it on our local machine. So to do that, what we're going to do is say, also, just so people are aware, your terminals will look a lot different to mine. I've configured mine to high heaven. Don't worry if it looks different.
The commands will work the same.
The commands will work the same.
It wasn't just out. Lowercase o out. And lowercase o output.txt. I don't know if that makes a difference.
Okay, so here I'm going to copy the file. This is the path. And then I'm going to copy it to dot, which means the current directory I'm in. It's going to ask me for my password. Not that one. Okay, and then you can see it copied output.txt to my computer. And then if I print the output.txt, you can see the file's copied over. Okay, so that was just a very simple example. We just went into java.bath, we transferred a file over, ran some commands, went in there in linux.bath. What did I say?
Java.bath.
That's a funky one. Sorry, linux.bath. Went to linux.bath, we ran some commands in linux.bath, transferred a file in, went into linux.bath, ran some code, came back out, copied a file back we just made there, and now we've got it here. Any questions about what we've just done? No? Okay, awesome. If anything's confusing or you do have any questions, please just put them in the chat. Let's remove all of that. Okie dokie. What else we got? Okay, the only thing I wanted to run through that we haven't yet run through is configuring linux.bath. So I've got a few servers that I sign into a lot. The main one is my Linode server. Linode is just a hosting site. I've just got a server. It runs my website and some code and a few things I just want to have running on a server. And it gets very boring typing in the address all the time because I never remember it and it's an IP address. So I've set up a little shortcut so I can just type in SSH Linode server. And okay, so now I've connected to my Linode server, and you can see I've just connected. It was very quick. I didn't have to muck around with passwords or whatever. That wasn't a password. Sure, we've got time. So I connected with a SHA key, which is, don't know what SHA stands for. It's a cryptographic key. So there's a private key, a secure hash algorithm. So there's a private key on the server, and I've got a public key on my computer, but I've encrypted my private key with a short passphrase. The reason I've done this is for security. So for instance, if one of you lot got hold of my computer, you would now know where my passkey is stored, where my public key is stored, because you just saw it, but you wouldn't know the passcode. And so you still wouldn't be able to get in. So for things like this, it's very useful to encrypt your key. You don't have to though, a lot of people don't. I don't think Joe does. Do you? I've not done it. For my Git, I haven't done it because Git I have to connect to so often I just don't want to have a cryptographic key. Because I've got Git set up to use SSH as well.
I have one of my servers.
Oh, okay, Joe does one of his servers, not for the other. Look at him flexing with the number of servers he's got. Jeez. Okay, so here you can see I've connected to my remote server. We've actually, if you look at the Unix tutorial, some of the stuff I was trying to teach you doesn't work on macOS, and so I went into my Linux server to run it. You'll see that, and now we've explained what that was. And we're going to leave. So you may want to know how to do this. So I've got the same thing set up for SSH linux.bath. So rather than having to type everything out, I can just type in SSH linux.bath, and it will know my username, it will know what address to go to, and then I've just got to grab the passcode. And then I'm in, and it's just much quicker than having to type out all the time. And so that's how you do that. Let's talk about how to do it though. We're only going to talk about it for macOS and Windows, no, macOS and Linux, because I don't know where the file is stored on Windows. Google it. And so we're going to go into, let's just get rid of all that. We're going to go into .ssh, okay? And then we're going to look in here. So here you can see all of my different server keys. I've got some server keys in, sorry, these are cryptographic keys. Got some cryptographic keys in here for Joe's servers and for my servers. I probably shouldn't be showing you them. And what we're going to do is we're going to look at my config folder. So this is my config folder. And what you can see here is I have saved different things. So ignore these first two, they're more complicated. We're just going to look at these bottom ones. So what I've said is host, and then this is called a host name. So basically, this is what I type into SSH to when I mean these things. So if I say SSH linux.bath, then it knows the actual host name I want to use is the host name of linux.bath, and the username I want to use is this username. There's also linux.bath, linux2.bath, and linux3.bath. The only reason you might want to use those is if you enter your password incorrectly too many times, it'll lock you out of one of them. And so you can connect to the other one. No reason. And here you can see I've got my GitHub set up as well for SSH. Cool. You can specify a bunch more stuff in here as well. With some servers, you can set this up so that it will actually, you can like log into a computer and it will port over the UI. So you can actually interact with the UI over SSH using something called X11. I've never done that, so I'm not going to talk about it. Linux.bath doesn't support it, so what do you do? And yeah, loads of other stuff you can specify in these. These are just configuration files, but I recommend doing something for linux.bath.
What does the star mean on the bottom line?
So in nearly all Unix and Bash, anything like that, a star is a wildcard. So this basically the way this works is it will try and match. So SSH doesn't just try one configuration, it tries a bunch of configurations. So it will try, so say I just connect to, like, I connect to linux.bath, and this login doesn't work, this user connection fails, it will then go down these list of hosts, sorry Joe, so the user connection layer fails, the user authentication layer fails, it will try loads of different ones. And then if none of them work, it'll just try signing in with that username and ask the user for a password. So this wildcard means if none of these work, try hostname GitHub user git with this identity file, and if this doesn't work, it will then just go to the username and password. But this means for all hosts. So I could have something here like. So for all hosts, try username, and so then when it's going through all the different ways it can try and connect, it will try using user alpha is cool, which won't work. This is just the way you've got to set up github.com, unfortunately. Or I don't suppose you have to, but it's the way they told me to when I set it up. Okay, so we've done that. Whoop. Oh, yeah, there's one more thing I want to go into. This is just cool. We've got a little bit more time. If you've got any questions, this isn't going to be an important thing for you. We've run through all the important things now. Send any questions you've got into there, into Joe.
This wasn't a question, but we've had a compliment about Apple and Panic.
Oh, thank you. We competed in Oxford Hack and made a thing. Talking of, to host the thing we made, we used Google's Cloud. To use Google Cloud, you have to connect with SSH. All connects. Remote server management. So we wanted to host our fun game, so we connected with SSH. Yeah. Yeah. Cool. So there's one last thing I want to do, and that is going to require us to SSH into linux.bath. Oh, I don't want to do this on my one. Okay. So I'm just trying to remember where it's stored.
Oh, is this your
Yeah.
thing? You've shown me it before. It was much easier than that.
It is. I just want to.
That's it.
Okay. What I'm going to do is. Good.
Copy it.
Oh yeah. Okay, cool. So I have something set up already that I didn't want to use because I've spent some time setting it up, so I've just copied it somewhere else, and then we're going to set up as if nothing had been set up before, like you would. Okay, so we're going to run a command called make home. This is a command specific to linux.bath, and it's going to ask us if we want to continue. Yes. Okay, so okay, so we are going to. It's going to ask us for a bunch of questions. Sorry.
What it is first.
Okay, sorry. So everyone in Linux, everyone in Bath gets. There's a special website that Bath set up for us called people.bath.ac.uk / what's your username? Do you have one set up?
JJCA2, I think it's set up for you. You did not.
Might not even be that. Sorry?
Just go with yours, right?
Well, I just deleted mine.
Like that.
I know what I can do. I know where one is. Here we go. Okay, so this is our friend's one. So if you go to people.bath.ac.uk / then a username, you can make a little website that's yours to display whatever you want. Okay, so here this is our friend Soren. He's got one set up to display this. But it doesn't have to be just this. You can put whatever you want in here. You can access the HTML directly. But in this case, we're going to use this program. So it's called make home. And then it's asking us for a name. I'm going to go with Mr. You can leave it blank if you want to just use the department. That's my degree. It's asking me for loads of things. It's asking me for an address. Asking me for an email address. Ask me for, no I don't. Okay, so we went through a whole process there, asked us loads of questions, but now if you go to this address, you will see I've got a little website, I've got a little page. and I can put whatever I want in here. This is with the power. So you can run this command on Linux, and then Bath will host a little website for you, or a website page at least. And this is where I can link stuff like my website, which didn't work because I didn't put HTTPS in front of it. But anyway, that's how you do that. It's a neat little thing.
What's the path to an HTML directly?
It is www slash it's this /var /www /html /index.html, and then you can edit the HTML directly. Styles. Sorry, what was I making with it? Got a lot of stuff in here. Where's my stuff? Maybe this isn't the right place. That's fine. Oh, never mind. I'm being an idiot. It's in here. You go to. It's just in your local directory. It's public HTML. So your local directory, public HTML index. Okay, sorry, here we are. This is what we're looking for. And so here you've got all the HTML tags, so I can change this if I want. And I want to fix my email, my website. And now if we go back to here and clear the cache, maybe not. Oh, here you can see it now says Alfie is cool. And this now takes me to the right page. This is my little website. Cool. Any other questions?
Does the page exist for as long as you're at Bath?
I would imagine so. I don't know. It will probably exist as long as you've got a Bath login. I know it doesn't reset every year because I set it up last year and it's still there. So I'm not totally sure, I'm afraid. What I want to do is show you. You don't have to use their CSS either. You can set it up to be whatever you want. So here you go. Here's my my algebra teacher. He is a people.bath. And you can see his looks completely different. And you can put whatever you want on here.
It's like, I think Nikolai has one.
He might just be Nick. It's not just Nick. I bet he does have one.
Yeah, he does. It's got all the...
Have you emailed him? Send in any questions you want while we're just working out how to look at working out our professors' usernames. MAS.
NNV.
That did not work.
MASNNV.
Here we go. Here's Nikolai's. You can see you can stick whatever you want in here. His is quite long.
You also, I think this is where he puts the problem sheets for first year and that kind of thing.
Oh, okay. Apparently he also puts his problem sheets up here, so you can have like sub-pages as well. Quite a lot of lecturers do this because they can just host whatever they want here. So yeah, here you can see the problem sheets. You've probably seen this website before if you're a first year. Apparently it's got some dead links. A lot of dead links. Okie dokie. Oh, okay, that's gone, apparently. Anyway, any other questions while we're here?
Does Fabio have one? I don't know, probably. Just, Fabio's email address, right?
Yeah, it's fab something. That's race.
I've got f.nemeth, that is not correct.
Map FN. Okay, he has got his one to redirect to a Google form about how things are going. You can do anything you want with your people.bath. Not anything you want. Don't put bad stuff on there. Don't blame us when they tell you off. Cool.
Okay.
All right. Well, thank you all for coming. Any questions? Google it. And if you can't find the answer from Google, send us a message. Or just send us a message if you're really confused.
Or if you just want to talk.
Or if you want to chat. We're just here to chat. We're nice people. Sometimes. Most of the time. Sometimes.
Hey.
Thanks for coming.